what if our entire view of reality is, well, wrong, or at least backwards? For centuries, we've thought of the universe as being built from all these tiny little parts, right? Particles. But what if that's not the fundamental layer? What if everything we see is just an expression of a single, unified field? That's what we're diving into today, a completely new grammar for the universe.
So, to even get into this new idea, we have to look at our old one. And let's start with a big one, dark matter. I mean, why was it even invented? Think about it. We keep having to add these patches to our theories just to make the math work. That's a huge clue, right? It tells you that maybe, just maybe, our starting point is a little bit off. All right, so here's the real heart of the problem. Our stable datum, our fundamental assumption for decades, has been the particle. We try to build everything up from these little bits and pieces. But here's the crazy part. That model only describes the 0.1% of the universe we can actually see. I mean, seriously, 0.1%? For the other 99.9%, we just invent things like dark matter and singularities to patch the holes. The field-first model says, hold on, you've got it completely backwards. What if particles aren't the cause of everything? What if they're just an effect, a ripple in a much deeper underlying field? So here's how we're going to break this down. First, we'll dig into the particle-first problem. Then, we'll reorient to the field. After that, we'll look at its grammar, this cool thing called the coherence metric, a law of nested scaling, and finally, what it means to see the whole system. All right, section 1, our particle-first problem. This is all about figuring out where our map of reality just doesn't match the territory anymore. You know, it's kind of funny. Our current models have things completely upside down. We treat matter, the stuff that makes up a measly 0.1% of everything we see, as the norm, and plasma, the electrified gas that makes up literally 99.9% of the observable universe, we treat that as some weird exception. It's like studying a single grain of sand on a beach and calling the rest of the beach dark sand. This new way of looking at it says, no, the plasma's the norm. Matter is just a tiny crystallized anomaly in a universe that is fundamentally electric. So that leads us to a really crucial shift in thinking. If particles are the anomaly, then what's the real foundation? Well, the answer is the field. And what's interesting is this isn't some brand new, out-of-the-blue idea. Way back, James Clerk Maxwell gave us these incredible equations that were all about the deep, coupled relationships inside the electromagnetic field. He was already hinting that the field was primary. So this is really about reorienting back to that powerful field-first perspective. And the cornerstone of this idea is something called the quaternion field, or Q star. Now, don't let the name scare you. Just think of it as the fundamental source code of reality. It's this unified thing that encodes both potential, like the pressure in a hose, and flow, the actual water moving, into one single object. They're not separate. In this model, everything we see, electric fields, planets, you, me, it's all just a projection, a shadow cast by this one fundamental field. Okay, so if this field is the substrate of everything, how does it build anything that lasts? I mean, how do we get stable structures? Well, the answer is that the field has a kind of operating system, a fundamental grammar with 9 distinct phases. This is literally the instruction set it follows to organize itself into everything we see. And here it is. This is what that grammar looks like visually. It's a 3x3 phase cell map. Now, this isn't some arbitrary chart somebody drew up. This is what emerges naturally when a field interacts with itself. It's a way of tracking phase, initiation, modulation, stabilization. And this is so key because our particle-first models have basically thrown the concept of phase out the window. That's a huge reason we're stuck with all this weird probability stuff in quantum mechanics. In a field-first model, tracking phase is everything. It's how you get determinism back. So that single grammar projects itself in 2 ways that are totally locked together. On one side, you've got the formative dynamics, the flow and the force, the stuff Maxwell's equations describe. On the other side, you have the containing geometry, the actual shapes, the boundaries that form. But here's the kicker. They're not 2 different things. They're like 2 sides of the same coin, 2 phase-locked expressions of the same underlying process. Okay, that's all great, but it's still a bit abstract, right? How do we actually connect this grammar to the physical world? We need a bridge, a kind of Rosetta Stone. And that tool is called the coherence metric. Now, this is really important. The coherence metric, which we'll call T, isn't a measurement in the way we usually think about it. It's more like an address. It's not telling you how much of something there is, it's telling you about the relationship between 2 forces. The formative pressure trying to create something, and the containing tension trying to hold it all together.
Conceptually, it's actually super simple. T is just the formative pressure divided by the containing tension. You can really think of it as a universal impedance ratio. It's the will to create versus the power to contain. That's it. And here's what that looks like in physical terms. Now, don't worry about memorizing the formula. Just look at the structure. The top part, the numerator, that's the engine, the motive, formative drive. The bottom part, the denominator, that's the harness, the containing field that puts a constraint on that drive. And it's the balance between this engine and this harness that tells you if something is going to be stable or just fly apart. So the value of T tells you the whole story. If T is way bigger than 1, the engine is overpowering the harness, and the whole thing just fragments and blows apart. If T is way less than 1, the harness is too tight, it's choking the engine, and the system just rigidifies, it can't flow. But when T is right around 1, well, that's the sweet spot. That's the magic address where form and function are perfectly matched, and that's where stable, persistent structures emerge. Okay, and this is where it gets really, really cool. This idea of coherence isn't just for one particular thing, it scales. There's a law of nested scaling that shows how this same principle builds stable systems all the way from atoms to entire galaxies. Here's how it works. Once you get coherence at one scale, say the atomic scale, where T is about 1, you get stable elements. That stable platform then becomes the building block for the next level up. So now you can get coherence at the molecular scale, which gives you stable biomolecules. And then that becomes the platform for stable cells. You see the pattern? It's a nesting doll of stability, building complexity layer by layer, all based on the same fundamental principle of T being close to 1. So, the big question, does this actually work in the real world? Well, let's go all the way back to dark matter. When you take this coherence metric and apply it to 175 real spiral galaxies, what number do you get? You get a t-value of about 0.89. That's incredibly close to 1. What that means is the flat rotation curves of galaxies, the whole reason we invented dark matter in the first place, can be perfectly explained. They're just giant plasma vortices operating at this point of near-perfect coherence. No dark matter needed. The patch is gone. And all of this leads to the final and maybe most profound shift in how we see everything. We're moving away from a universe of separate little parts and toward a vision of a deeply unified, coherent system. This new perspective really reframes everything we thought we knew, even something as basic as energy. Check this out. Energy is not primitive. It is the cost of incoherence. Let that sink in. Energy isn't the fundamental stuff of the universe. It's the price the system pays for being out of balance, for being incoherent. You find coherence, and the energy required to sustain the system just collapses. So the big takeaway here is this massive shift in perspective. We're going from a universe of separate billiard balls bouncing off each other to a universe that's a unified whole, a whole made of nested, coupled field relations. In this view, everything, absolutely everything, is just a pattern, a resonance inside one single underlying field. And the most beautiful part? The same simple rule, this same grammar applies everywhere, at every single scale. From a single cell to a massive star, the pattern is the same. The recursion holds. And that leaves us with a really big question to think about. How will our systems, our technology, our societies, our way of thinking, how will they reorganize now that we're no longer seeing a world of fragments in separate parts, but instead we start addressing the system as what it is, a coherent whole of nested, coupled field relations?